Yeah, some of you did do the homework, but it needs to be done on paper, and I want to make sure that you did it the way that, well, it doesn't matter how you did it, as long as you didn't just click yes on all of them and then switch it to no if you got it wrong, because that doesn't help you at all. Okay, so today we're going to be identifying whether or not an ordered pair is a solution to an equation. So I'm going to give you linear equations. They're not all in the form that you're used to, which is slope-intercept form, but they're still considered linear equations. And here's our point. So we're going to decide, is this ordered pair a solution to this equation? And I want to remind you that in an ordered pair, this is your x value, and this is your y value. So what we're going to do is we're going to plug in our x and our y here into our equation and just see if the equation is true. Okay. So all I did is I plugged in 3 for x, -2 for y, and now I'm going to simplify it. So remember to multiply before you subtract. Okay, so -3 times -2 is a +6. Is 9 equal to -9? No. Okay, so we can say this point 3, -2 is not a solution. Okay? That's all you're doing. So let me give you a couple practice problems to try, and then I'll show you how to do it from a graph as well. Okay, plug it in, try it out. Oh yes, you do need the point. I guess that would be important information to have. I was just keeping you guys on the edge of your seat.
was it said?
A sixth grader being a sixth grader. All right. For number 1, is it a solution? Yes. Let's just make sure. Oh yeah, I can see it. Yeah, negative 15 is equal to negative 15. So yes, this is a solution. Okay. And then let's try this one. Wait, is this a solution, number 2?
No.
No? Okay. Okay, I'm getting negative 4 is equal to positive 4, which is not true. So I would agree that that is a no. That is not a solution. Okay. Okay, now I want to show you what it looks like when we're trying to figure out if a graph represents the equation given. Okay. So we have the equation y plus 2 is equal to x plus 6. I purposely didn't put it in slope-intercept form because then you would be able to see the y-intercept and the slope, and I really want you to try a different method for making sure it's correct. Okay. The graph has a y-intercept of 4, and it has a slope of negative 1. So when you're graphing this to look at, the y-intercept is 4 and the slope is negative 1. Okay, so when you're given a graph and you're asked whether or not this graph represents the equation, what you're going to do is you're going to pick a point on the graph and test it just like we just did. So in this case, like I could just pick a point. It doesn't matter which one. I'll pick this one. This is the point 3, 1. So I'm going to plug in 3, 1 for my x and for my y and see if it's true. And it is not. It is not true. So we can say that no, that graph does not represent that equation. Now I want you to be careful because sometimes, like for instance, if I plugged in the y-intercept here, which is 0, 4, it would have been true. But that is because for this equation, your slope is a positive instead of a negative. So I would avoid plugging in the intercepts. I would pick points that are not on the x and y axis when you're testing it. It'll be more accurate that way. All right? Okay, you have homework, which you have enough class time to finish. And it needs to be done on paper, and you need to show your work, okay? And you'll turn it in on Monday. And then if you have extra time, you can keep working on those IXL codes. I actually figured out that I could go in and star them, so that when you guys log in, on the right side, it will say like your starred ones, and you can just click it and go down. Now, some of you are getting hung up on some of the IXL lessons, so if you are struggling, let me know and I'll help you. And you can skip around too, and I did add one new lesson, but it doesn't have a code. It's kind of weird. It's just a dot. Okay, so take a look at that when you're done with your homework. Omar. No, you don't have to graph it. Yeah, Trent. I can't hear you, so I'm going to walk around, okay?